Student, let us see the relation among EMF, terminal potential, external resistance and internal resistance. To understand the relation among EMF, terminal potential, resistance and internal resistance, let us take an external resistance across a cell having internal resistance as shown in this figure. So this is positive charge, negative here, positive terminal, negative terminal, this is internal resistance, give a dotted line, this is said to be cell. This is external resistance R. I is the current moving from the cell to the circuit. Now apply Ohm's law. According to Ohm's, V equals to IR. So in here we will write V equals to I into R. This is voltage across this resistance. The current come from this positive terminal, complete the circuit and enter the inside the electrolyte. So here also we have resistance. So here we write V dash equals to I into small r. Now this V dash and this V is given by the cell of EMF E. So we have EMF E is equals to V plus V dash. Let this be equation number 1. From here E is equals to V plus IR. So E minus V equals to IR. So R is equals to E minus V divided by I. According to Ohm's law, V equals to I into capital R also. This means that I is equals to V upon R. So you will write small r internal resistance is E minus V upon, at the place of I write V upon R. This equation become E minus V divided by V into R. And this equation give you E by V minus 1 into R. So you have the relation internal resistance R equals to E upon V minus 1 into capital R. This is the expression for internal resistance, equation number 2. This is the expression for internal resistance. Small r equals to E upon V minus 1 into capital R. Now let us have another equation for current. From equation 1 we have E equals to V plus V dash from equation 1. Since E equals to V plus V dash, so you write at the place of V I into capital R, at the place of V dash I into small r, take out I outside, R capital R plus small r is equals to E. So I is equals to E upon R plus small r. This is said to be expression for current when you have internal resistance as well as internal resistance. Equation number 3. Based upon this, let us solve a question. A numerical for you. In this numerical, the given values are suppose I am giving EMF E is equals to 10 volt. In internal resistance R is equals to 3 ohm. Current I is equals to 0.5 ampere. You have to find external resistance R and you have to find voltage V. According to question, we have this given data. So we have to find resistance R and we have to find voltage V. What will be the formula for EMF? Just you know that EMF E equals to V plus V dash. So here you have E equals to V plus V dash and we have to find capital R from here. So we can write this is I into capital R plus I into small r. So this is E. you have to find this capital R, external resistance. So you can rewrite it, E upon I is equals to R plus small r. So capital R is equals to E upon I minus R. Formula generated, put the value. E, EMF is 10, I, current is 0.5, minus small r is 3. So here you eliminate this point, you have 10 in the numerator side, 5 divide 10, 2, so you have 20 minus 3 equals to 17. Unit of R is ohm, 17 ohm. So just you have R 17 ohm. Now you have to find V. Part A is determined. Part B you have to find V. So V is equals to IR according to Ohm's law. What is I? I is given 0.5. What is R? Capital R, just determine, it is 17. Multiply this, 5 into 7, 35. 5 into 1, 5 plus 3, 8. And substitute the decimal point, 8.5 volt. Here also it is clear that EMF is 10 volt and terminal potential is 8.5 volt. This is a NCERT book question, okay? You must follow NCERT book. Later on we will solve the questions of NCERT book also. For more details on physics, you must subscribe my channel, okay? Thank you.